All right, welcome. Today, we are firing up one of the most incredible biological systems you can imagine for creating amazing plant fertility. We're talking about the vegan nitrogen engine. I mean, just think about that for a second. What if you could make seriously powerful fertilizer with basically sunlight, water, and stuff you already have in your kitchen? No expensive inputs, no animal waste, just a living system that literally pulls plant food right out of thin air. Well, that's not science fiction, it's the biological reality we're going to unpack right now. Okay, let's dive right in. We call it an engine for a reason. It's this dynamic, living process that you actually build and run yourself. And in doing so, you're unlocking a natural code for creating fertility that just keeps on going. So what's the big idea here? At its heart, the concept is actually pretty simple, but it's also kind of revolutionary. We're talking about a biological reactor that grabs nitrogen from the atmosphere, the air all around us, and it digests waste products like organic acids, turning them into a premium plant-available fertilizer. And maybe the best part? It's 100% veganic. It completely breaks our reliance on any animal byproducts. And this is where it gets really interesting when you see it side by side. Conventionally, we think of nitrogen as something we have to go out and buy, either as a synthetic chemical or some kind of animal product like fish emulsion or urine. And those are often expensive and they can be really volatile. The vegan engine just flips that whole idea on its head. This is a do-it-yourself, super low-cost system that creates a stable, biologically active product right in your own backyard. Okay, so if this is an engine, who's actually doing all the work? It's time to meet the heroes of our story, an absolutely incredible group of microbes known as purple non-sulfur bacteria. The main player here, the star of the show, is a species called Rhodopseudomonas palustris. And people call it a metabolic Swiss Army knife, for good reason. I mean, think about that. It's a photoheterotroph, which is really just a fancy way of saying it uses light for energy and it eats organic matter for its carbon. And it does all of this in an anaerobic environment. That means with no oxygen at all. And just look at this list of superpowers. I mean, these bacteria are a total powerhouse. They pull nitrogen right out of the air. They digest nasty stuff like ammonia that can actually harm your plants. They even produce their own plant growth hormones and the building blocks for chlorophyll. And the final result of all this work? A liquid that is just teeming with high-value single-cell protein, which is basically a perfect 5-star meal for your plants. All right, this all sounds fantastic, right? But how do you actually do it? How do you get started? Well, now we're moving into the practical, hands-on part of this. We're going to go from a little bit of pond mud to a seriously powerful liquid fertilizer. First things first, you've got to find your local workforce. And you do this with a really simple device called a Vinegar column. All you need is a clear 2-liter plastic bottle. You just layer in some mud from a local stagnant pond or a ditch, add a carbon source like shredded newspaper to get the fermentation going, top it off with pond water, seal it up tight, and wait. See, the microbes are already out there. You're just creating the perfect little apartment for them to move in and show you what they can do. All right, now for the food. This is the recipe that's going to make our captured bacteria thrive. It's the fuel for your engine. You've got molasses for carbon, soybean meal for nitrogen, a pinch of Epsom salt for magnesium. But the real secret ingredient here is the white vinegar. The acetic acid acts as a selector. It creates an environment where our target PNSB absolutely love it, while other microbes, not so much. The baking soda is just there to help keep the pH in that happy zone. The process itself? Super straightforward. You mix up your ingredients, you add your starter culture from that Vinegar column, and then, and this part is absolutely critical, you seal the bottle with 0 headspace. Fill it right to the very, very top. This forces out all the oxygen, creating the anaerobic conditions that these PNSB need to thrive. Then you just place it in the sun or under a warm light and let the magic happen for about 10 to 14 days. Now, here's a crucial step you cannot miss. Your culture, once it's mature, is kind of dormant on the shelf. So before you use it, you have to wake it up. We call this SOP 401. A day or two before you plan to apply it, you give it another little shot of food, like molasses. Seal it back up in the light with 0 headspace, and this brings the microbes to their peak activity. This ensures you're delivering the most potent dose possible to your plants. And check this out. When it's finally time to use it, you'll see just how ridiculously powerful this stuff is. You dilute it at a ratio of 1 to 1,000 with water. No, that's not a typo. A tiny, tiny amount goes an incredibly long way, delivering a powerful root drench that's packed with that valuable single-cell protein.
Okay, so how do you know if you actually did it right? The great thing is you don't need any special equipment, no lab coat, no microscope. This is the sensory audit. You just need to trust your own eyes and your own nose to know you've succeeded.
Visually, the transformation is just stunning. For the first few days, not much seems to be happening. But then, as the bacteria really start multiplying, you'll see the colors shift to a pale pink or a rusty red. But the goal, what you're really waiting for, is that final stage, a deep, opaque, vibrant purple or crimson. That rich, beautiful color is the sign of a dense, healthy, and mature culture. It's ready to go. This slide lays it all out. Here's how you know you've nailed it versus, well, when you need to start over. Success is that deep red purple color. And you'll notice the smell completely changes. Any sharp ammonia smells will fade away and be replaced by this savory, earthy umami scent, almost like a rich broth. That's your goal. Now, on the other hand, if you see bright green, that's algae, probably from an oxygen leak. If it smells like rotten eggs or that sharp ammonia smell never goes away, the wrong microbes took over. Don't risk it. Just discard that batch and start a new one. Now that we know how to build the engine and how to check our work, let's zoom out a little bit. How does this protocol actually plug into a larger strategy for creating truly resilient, healthy plants? I want you to think of plant health as a 3-level staircase. Level 1, the foundation, is all about establishing the soil stomach. That's a thriving fungal network from something like a potato JMS that maximizes photosynthesis. Our vegan nitrogen engine, what we're talking about today, is level 2. It is the key to robust protein synthesis, building the actual structure of the plant. And this, in turn, allows the plant to climb all the way up to level 3. And this is the key connection. A plant can't build its defenses if it's struggling just to grow, right? The incredibly efficient protein production that's fueled by our nitrogen engine at level 2 creates the energy surplus a plant needs to build its level 3 lipid shield. That's the waxy, physical armor on its leaves that naturally repels pests and disease.
And that really brings us to this final thought, which I think just says it all. This knowledge isn't hidden away in some university lab. You possess the code. You know how to build the reactor. Now you can go out and start your own fertility revolution. So really, the only question left is, what are you going to grow with this incredible purple gold? The potential is sitting right there in a bottle, just waiting for you to unlock it.